the natural logarithmic function integration. We will, in this section, use the log rule for integration to integrate a rational function, and we'll also study how to integrate trigonometric functions. Given that the derivative of ln of x is 1 over x, we have the integral of 1 over x dx equals ln of x plus c. You are certainly noticing the absolute value here for x. It's important to remember to write them. The reason is 1 over x is defined for all real numbers. So when we take the derivative of ln of x, which is defined only for positive numbers, this domain carries on to the derivative. Here we have a function that is defined everywhere, and therefore we need an integral that is defined everywhere as well. Example 1, the integral of 1 over 2x dx. Very easy, we can just extract the 1/2. So we have 1/2 times the integral of 1 of x dx, and therefore the answer is 1/2 ln of absolute value of x plus c. If we want to integrate 1 over 4x minus 1 in the next example, we need to use a change of variable. U equals 4x minus 1. From that we find that du is 4 dx, and therefore dx is 1 over 4 du. So we make these substitutions and we get the integral of 1 over u times 1 over 4 du. There's a mistake here, and this should be a du. We need a variable of integration that matches our variable. And the 1 over 4 can be brought in the front. We have 1 over 4 ln of u times ln of u plus c, with absolute values every time. By changing u back to 4x minus 1, we have this final answer. In this exercise here, we will again make a change of variables. U equals x cubed plus x, and therefore du equals 3x squared plus 1 times dx. The reason why this is a good move is going to be very clear soon. If I change the denominator x cubed plus x to u, and I change dx to 1 over 3x squared plus 1 du, I notice that this and that cancel out, so this simplifies to 1 over u du, and therefore the integral is ln of absolute value of u plus c, which, when changed back to the variable x, becomes ln of x cubed plus x plus c. As you've noticed, the very important thing to be able to recognize when you start an exercise like that are situations where we have u times u prime dx. That really tells you that you found the right change of variable, and the reason for that is that u prime dx is actually equal to du. So in the example above, if I look back here, this was u prime, and u prime dx is equal to du. I didn't make the change like that here, but we could do it like that, and I think I do it later on. In the next exercise, we see exactly that. We have tan of x at the denominator. If we set up u equal tan x, then u prime will be secant squared x, and that's a very good sign. If I make the change dx equals 1 over secant squared x du, these two cancel out, and the answer is ln of tan of x plus c. This exercise is a little bit different. We don't see that we could have u prime dx anywhere. What we need to do here is first use long division. X squared plus x plus 1 divided by x squared plus 1. If you use long division, there's as many ways to explain long division as there are teachers, but you know how to do it, and you would find that you can rewrite this as the integral of 1 plus x over x squared plus 1 dx. And now I can create a situation where this is going to be the derivative of that by multiplying and dividing by 2. The integral of 1 dx is not ever going to be a problem, but here x squared plus 1, if I do a change of variable u equals x squared plus 1, I will have u prime dx here, so I'll be able to change this to du. And the final answer is right here. The integral of 1 over x ln of x dx. At first, we can't necessarily see how to solve that problem, but when we rewrite it like this, the integral of 1 over x over ln of x, it suddenly becomes quite obvious. U equals ln of x and u prime equals 1 over x, which means I'll have a situation where I have u prime dx, which is equal to du, and therefore the integral is ln of the absolute value of u plus c. So the solution is ln of x plus c. The integral of tan x dx can be found using the same technique. Tan x is sine x over cosine x, and with a minor change here, negative signs, we have the same pattern. We have u equals cosine x, and at the numerator u prime times dx. So once again, we can find that this is going to be minus ln of the absolute value of cosine x plus c. So there we are. The log rule for integration is what we used many times to solve integrals, and we've also seen how to find the integral of tan x dx. This can be done with other trigonometric functions too.